What I want to cover today is what MariaDB has done in terms of security. So that's why the title was a little bit misleading before, to cover the security topic as such, but also how this set of technological features can help to meet GDPR, which is the buzzword of the year, at least here in Europe. So we have seen, who has been in this business for a while, has seen that the sources of data breach and data stealing or data accesses from malicious users or malicious people, let's call them this way, is very common, very more and more difficult to prevent, but this is what we want to stay at the pace. So we want to keep this data protection and to prevent our customers' data from being stolen or accessed by other people. So some of the accesses actually come from untrusted pieces of software. So this is a quote released early this year regarding how components of very well-known technologies can actually compromise or become some sort of back gate to access our data. I was in a WordPress conference in April in Turin. There was a 2 days workshop, national workshop around WordPress, and not many were aware that part of what they normally use might jeopardize their job. So disclosure first, I'm not a GDPR expert. I don't want to put myself in this position. Of course, I've been through this for more than a year now because all our MariaDB customers are involved, especially because I cover the SC role in the EMEA area. They normally ask. And what they normally ask is MariaDB GDPR compliant? And when they ask this question, I normally understand that they don't have a clue about GDPR, because a piece of software can't be GDPR compliant. It's a company that has to be GDPR compliant. MariaDB can help from the database point of view to prevent and to help from the technological perspective to allow a company to become GDPR compliant. So what I put together is a set of things that really come to my experience. And this is the way I see GDPR. GDPR is a matter of balance, a balance between processes, technological solutions, and compliance. And of course, processes are something that the company needs to understand and cover. What we normally, or not normally, but often see is that companies are not fully aware of the data flow, where the data really come from. They have some idea, but sometimes they don't even realize that they have other sources of data that are thrown into their databases and they were not aware about. Technological solutions are just covering a part of the GDPR process, so everything that's related to what is really technical. So data encryption, GDPR explicitly mentioned the word pseudonymization that probably nobody heard about before last year, and now we all mention this pseudonymization action or activity. And of course, everything that can, from the technical point of view, prevent data from being read or, worst case, even stolen. And compliance is something that, of course, is related to the rules, related to the regulamentations. And one thing that is important to be aware of is that these three things, or at least the way I see them, are putting together this process and this idea of the balance, which is just a starting point. Once you have a nice awareness of what your processes are and how you technological can cover the technical requirement and you are compliant with the rules, this is the starting point. From that on, you need to continue to be aware of the new regulations, the new rules, to be aware of new risks and new technical ways to prevent or protect the company for this. So just recapping, what are the GDPR requirements? You probably are all aware now. The idea is secure by design. So this is the mandate. Everything has to be secure by design. So we need to think first about security. So we need to have the idea of security since we start storing data, not even in the database, because this of course refers also to documents in the file system, to our emails, to everything that's I would say part of the company assets. And the idea of secure by design is of course based on the idea of risk. So a company, and this is part of the processes I was talking in the previous slide, has to evaluate and to be aware of the degree of risks that the data asset could be exposed. If you're running on a single server in your room, not connected to any kind of internet, the risk is probably down to 0. If you are in a protected network with a lot of firewalls and with a lot of your data are probably already secure. If you're in between, you need to understand exactly what is the degree of risk you're exposed to and try to put some sort of fences or protection around those. Talking about the processes, as I said, sometimes we don't even know where all our data come from. So the idea is to have a nice way to go through this, and this is something that is part of the company data management or even knowing about the nature of the business. Where do we from where we do insert data? So again, it's something that is normally related to be able to answer all these kind of questions. Where data come from, who is managing them, why we are storing this data, where are we storing this data, how we do manage this data. So whenever we are able to answer all these questions, we have probably a nice view of our processes. In terms of technology, what GDPR explicitly says is that it's important to implement technical measures that ensure a level of security appropriate to the risk. So again, talking about the risk, the measures that you have to set up and to put in place need to be appropriate. And it talks explicitly about pseudonymization and encryption. So this is just to tell you that there is not much in terms of technical requirements in GDPR, in the GDPR regulation. 90% is related to processes. This 10% related to the data security is anyway critical. Okay, so you need to know a lot about who, where, how, and sometimes also to redesign your database in order to reduce to the minimum the risk of data being stolen. Because the more you anonymize your data, the more you organize your tables in a way such as your critical and protected data or personal data or personal in terms of security and privacy data are put in a specific table, just to have an example, and not distributed all around the database, the much easier is to protect your database. You can just encrypt the table, you can just have this data protection really focused on what's really critical and you need to protect. So the protection and the technical aspect is including not just the encryption, so how to encrypt data and how to prevent any malicious usage of this data from being pursued or to prevent, even in the worst case, that these data are stolen, that they can be used because they are encrypted and nobody can read them. But we also need to prevent the database to be accessed. So we need to put together all the possible technical ways to prevent data. And we'd also want to prevent unauthorized users to access the database. So this prevention, of course, talks about, refers to firewalling, to have a sophisticated as much as possible, again, based and evaluated based on the risk of authentication, and to encrypt everything that's in motion, not just at rest, and to be sure that we are backing up everything, and everything that we back up is anyway encrypted. So to be sure that all our data management is protected. Auditing is an important part. I will talk about auditing a little bit more. It's becoming more and more relevant. With MariaDB, we are facing more and more customers in the finance area, banks, trading companies, online banking companies, online payments solution and infrastructure, and this auditing is becoming critical for them. Because again, following the GDPR recommendation, one of the rules says that in case of data breach, you are forced to notify the authority that this data breach has occurred within 72 hours. So if you notify, you are also then asked to prove that you have put together all the possible technical solutions to prevent this from happening. And even if with all those means set in place, you had this data breach, a nice auditing can at least prove black and white that you were checking everything that was happening in your database. And this is something that we can absolutely cover with MariaDB. So what does MariaDB do in terms of GDPR and let's say covering the technical part of the GDPR requirements? Through the MariaDB tools, so MaxScale and MariaDB database, you can cover from the firewalling point of view, so from the data access prevention, to prevent unauthorized users to access the database, to prevent bad queries to go to the database, to encrypt everything, data at rest and data in motion, and also execute a nice auditing process. So this is a slide that might seem complex, but it's actually, at least the way I see it, very, very clear. So from left to right, you can see all the components of the security stack that is part of the MariaDB and that is covering the technological part of data protection. We will go through this from left to right. So from left, we can see the MaxScale. I don't know, do you know MaxScale? Are you all familiar with MaxScale? So MaxScale is a database proxy. It has been designed to work based on the MySQL protocol. That is also the protocol that is used by MariaDB, of course. And MaxScale has been developed around a very lightweight core based on Linux primitives and a set of plugins. So one of the, probably the father of MaxScale will also have a conference, a talk today in this conference. And the idea of having a lightweight core surrounded by lightweight plugins as well, so each of them is in charge of a specific action, of a specific activity, makes this architecture really flexible. So the design at the beginning was intended to have a database proxy, so something between the application layer and the database layer, something the application can connect to, and that responds as if it were the database. And then it is also in charge to route all the queries, to route all the requests, or to filter all the requests toward the database layer underneath in a transparent way for the application. So MaxScale was designed to be basically, as I said, a database proxy. And then based on this nature, that is a piece of software that is decoupling the conversation between the database and the application, it was also easy to design plugins for MaxScale that were intended to cover some sort of security and firewalling, because exactly it stays and it lays exactly where a firewall should be between the application and database layer. So as you see in this slide, it's part of the plugins that are the default plugin for MaxScale are plugins that support the monitoring activity. So the monitor is actually checking the health check of the database infrastructure underneath. Routing the queries like the read-write splitting, so routing all the writes on the master and the reads on the slave, so you can take advantage of all the servers that you have in your infrastructure, whether there is a master and slave solution or a clustering solution, and also to manage the failover. So in case of master failure, in case of even in the multi-master solution, in case of failure of one of the nodes, MaxScale is able to fail over in a transparent way for the application. So just an overview of the main features that are related to the MariaDB MaxScale routing. We will talk a little bit more of all the things that MaxScale can do in terms of firewalling and security. So one of the plugins that you've seen in the previous slide is called filter. Filter is a generic definition of something that can filter what comes from the application and prevent those from accessing the database. So a filter can be created by the user. There is nothing pre-written, pre-shaped, so it's basically something that you can put together with rules, regular expression, something that you want to design your own, something that you already have in your organization, something that is part of your background. And you can tell MaxScale to filter out all the queries that are part of a list. Let's say that you know everything about your application and you know exactly the list of queries that this application is sending to the database. You can tell MaxScale, this is the list of the queries. If something comes that is not in this list, just bounce it. We don't want anything else that is not in this list to touch the database. Of course, you can also have a blacklist. So you can tell MaxScale, this is the blacklist that I will never see. I will never want to see touch the database, even if they come from the application, from a trusted source. This kind of queries should never touch the database, because this is something that we don't want. Something like a select star without a where clause, or something that is badly designed in terms of data protection. You can also limit the number of queries that will touch the database, but we'll see this in detail. So this is how does this work? Let's say that we have a query like that one, a select star from customers. This is potentially a query that can steal all my data set from the database. It's a query that can, it's a nice query from the SQL point of view, but from the data protection point of view, if it touches the database, it's basically retrieving all my table and giving the contents out. This is something that we might not be willing to happen. So you can tell MaxScale that whenever a query like that happens, you can throw either an error or return 0 records in the data set, in the result set. So this is a set of examples. So these are the typical matches that we normally see in the data in this filter. So where date and time, where close, where type, that. So they need to match some sort of rules. Another way to see this filter is also to prevent the SQL injections. SQL injections were, I would say, pretty popular in the worst sense of this, of seeing them in the past, but there are still many, many, many around. Again, sometimes written in those plugins that come from third-party tools, WordPress, Joomla, all these framework that have open source plugin developed by open source developers or developers that are probably not super controlled in terms of security. So this is something that we can also prevent. And this is one of the example, the typical a typical SQL injection example, and this is something that you can filter out. I have added this. Some of you probably know this XKCD comics, and this is one of my favorite. So this mother who called his child like a SQL injection, and so when I inserted the child in the school directory, they basically broke the database. So this is the name of the child. So drop table students. So this is something that we don't want to see happening in your database. Denial of services. Again, this is another way to see the MaxScale filtering activity. You can tell MaxScale that you just want a specific number of rows to be returned if a query comes that is potentially returning a large number of rows. So you can tell, even if I get this query, the query is well written, there is a where clause, there is everything that seems to pass the first degree of filters, I don't want to return more than n number of rows back to the client. So you can decide if you want to return 0, if you want to return the maximum, but this is something that you can configure. So you can also prevent the denial of services in terms of connections. So you can tell MaxScale, in case I have several connections coming from different sources, to prevent them to be created and then kill basically the server. So you can, in this sense, create a thread pool, a connection pool, and keep this alive. So every new connection is actually reusing existing connections and not opening new threads on the database server. This is actually another way of using the filter. So to limit the rate of queries using this firewall, you can tell if more than 15 queries are received in 5 seconds, block all queries for 10 seconds. This is another way to prevent applications that are actually hitting the database in a continuous way from being served all the time. So if this happens, and you can specify the time sets and the time frame, you can tell MaxScale to opt them out in different ways. You can return a limit number of rows. You can tell what to do in terms of blocking this malicious activity. It might not even be malicious, but in case something happens from the application side or from the client side, it is actually compromising the way the database is responding to the client. You want to prevent this. Security, again, with data reduction, this is probably the American way to translate the pseudonymization, which is probably a little bit difficult to say. What you can do from the MariaDB MaxScale point of view is to mask the result of a select. Let's say that you have your application who's reading the database, but you don't want all the users for security, privacy protection, not all the users should be allowed to read all the data, meaning that the application should be able to mask some of the data depending on the user who is requesting access to this. If I am in the finance company and I'm the CFO, I might probably be allowed to see everything. If I am one of the employees who is managing the sales processes and all these kind of things, I probably don't want, I should probably not be allowed to see in clear a credit card number or a security or a health value related to a specific person. This means that you have to change something in your application. if you want to be strict and even more strict, you need to rearrange your code. With MaxScale, this is something that you can do at the MaxScale level, and this can make probably the life much easier when you have to adjust and readjust and to be more consistent with the new regulation and the new requirement of the data protection. So what does MaxScale do? Basically, when it gets a query like this, when credit card number is mentioned, where a specific ID is also mentioned, you can tell MaxScale when this happens, just mask the credit card num with a specific pattern. And this is something that you can customize. You can partially obfuscate this number, like what we normally see when in the credit card numbers when we have access to the last three, just to be sure that that's exactly my credit card, but we don't want anybody to see all the rest. Or you can ask MaxScale to mask completely the column once it's mentioned and once it's required by this specific user. So this can give you a lot of flexibility to create, again, rules to mask your queries without having to touch the application again. Second block, encryption. Data in motion, everything that goes between the client and the MaxScale and the server, among masters and slaves. All the connections are encrypted, so every data who's moving is actually encrypted, so no man in the middle can read anything in the connection, through the connection and through the data communication. So even through the replication, I mean, the connection between the master and the slave is encrypted as well. We do also encrypt data at rest, of course. We have the granularity down to the table level, so we encrypt MariaDB tables. We don't have column encryption. This is something that you can only do through the application at the moment. And this comes from a specific requirement, actually. I think we will end up in having column encryption as well. But the idea is that when you really need column encryption, this is something that is probably related to the nature of the application. And so normally the companies want to have control on the key management, encryption management from the application layer. So we encrypt all the tables, as I said, and table spaces, InnoDB and area tables, all the binary logs and all the logs that are on the database. So everything that is database related and it's lying on the disk is encrypted. It's absolutely transparent to the application. It's something that you configure when you start the server. It also brings a little bit of low performance overhead, but this is, of course, part of the cost. I think that nobody is actually surprised. It's not more than 5–10%. It depends a little bit on the size of the tables and also on the number of the tables that are actually encrypted. We also have APIs to allow to create different encryption plugins and to manage encryption keys. With MariaDB, we have support for Amazon key management system. So we have a plugin that manages the Amazon KMS. And we also, of course, we do manage the simple key management through files and through the standard encryption files and encryption key. We do also have a third-party solution, which is made by a company, German company, who specialized in encryption in data management. It's called Iperi. And they have developed an open source plugin for MariaDB that can be used. Of course, this is something that we have because many of the customers did not really have a good key management strategy and they wanted to be helped in this encryption process by a third company. Authentication plugin. This is part of the MariaDB. So we also have an authentication plugin at the MaxScale layer, so they basically behave the same way. This is something that we added, I think, 2 versions ago in MariaDB. A couple of plugins that are designed to enhance the quality of the passwords. So we have 2 password validation plugins. One is to ensure that the passwords are well designed, so they at least contain capital, special characters, all these kind of things. And the other one is basically integrating this one with a set of checks that prevent users from having too simple password or too easy to detect, to guess password. So the combination of 2 plugins can ensure that we have a good password policy within the database. We also have been listening a lot to what our customers are using, and so we added support for external authentication in MariaDB. So we do support PAM, so LDAP authentication, and Kerberos authentication. So this is just an example on how normally the Kerberos or Active Directory authentication works. So see, this is why this is how normally we see the ticket going back and forth, and at the end granted the access to the database. MariaDB also comes since MariaDB 10, I think, with role access-based control, so it's much easier to group all the users that we have, all the database users, under the same, under a specific group, and to make database administrator life much easier. They can have a typical setup for roles and then just add new users to this set of roles with the set of privileges that we want to grant this group to. Auditing. As I said, I was talking a little bit about auditing at the beginning. This is something that we will see more and more, because it's one of the evidences that we can show that can explain that we have something in place, that we are checking what's happening in the database. There are several tools that are tracking and logging what comes to the database from outside. From the security point of view, and from what also the legal organization or the state organization, it's really not that relevant to monitor from a legal perspective what comes to the database. The audit must be done within the database. So it has to be written by the database itself, because it's the only trustworthy source of information for this. Only the database knows exactly what has been happening in the database. So that's why the audit plugin inside MariaDB is much more relevant from the legal point of view, when you have to prove, and also to try to discover, to detect who did what on your database. You go through the log and you see exactly what happened. So from the granularity point of view of the audit plugin, and this, I was 2 days ago in Brussels, and one of the customers that we have that's in the online payment in retail market, they just told us that their local authority went through the result of their audit made on MariaDB, and they passed. So from the quality point of view, also from the legal perspective, the result of our audit plugin is, I would say, trustworthy and well accepted by the legal authorities. So we can log everything that is related to the connection to the database, the queries that have been sent to the database, the tables that have been touched. We also track the views. And when we talk connection, of course, we monitor who connect, who disconnect, who tried to connect and then failed. So all the attempts to connection that were not actually executed at the end. All the queries that touch everything, not just the data, but also from the DDL point of view. And we track all the objects that have been touched. The audit plugin can be file-based or syslog based. It's up on the database administrator or up to the security company policies to define. Of course, the syslog is normally required not to stay on the same server where the database is. This is something that we have seen more and more happening, that security third parties ask to have this in another place. Syslog can be in another place. In theory, you should even not be allowed to change in any way the log file, so it should be read-only even for root users, which is kind of difficult, but yes. But in theory, the legal authority asks that once the log has been sent somewhere, nobody should be able to touch it anymore. They even say, especially in Italy, which are kind of interesting in terms of bureaucracy, the ideal would be that the log file could be recorded on a CD-ROM. So once it's there, nobody can change. Of course, this is not always doable, mostly never. Last but not least, those are old friends of MariaDB. These kind of features have always been around. The limitation per user. So this is something that is not new, but it's probably part of the way we want to see the database. And so the limitation per user. So you can tell MaxScale on the user base, and then we can go back to the idea of groups and to group users in this perspective, to have users that are allowed to execute just this limited set of operations on the database. So a number of statements that can be executed, the number of simultaneous connections that a user can set up, and how many queries they can have per hour. So one of the examples is that you can see here is that this specific user has been allowed to execute only this number of queries per hour, only this number of updates per hour, on this number of connections per hour, and so forth. Last but not least, with the MariaDB support, you are also notified on all the security and CVEs that might happen. So this is part of what we do normally provide our customer with. And this just to complete also the security point of view, from the discussion from the security point of view, also from the code point of view. And that's it. Any question? Okay, thank you so much.